Hello, welcome back. Okay, so in the last video, we were talking about formulating hypotheses and typically putting it into this kind of form, where we have our null hypothesis, which is the sort of status quo, right? It's the norm. And then we have the alternative hypothesis, which is challenging the status quo. Okay, typically this is what we come up with, and this is what is already known. Now, in this video, I'm going to kind of combine step 3 and step 4 into the same thing because step 3 is fairly simple. Just like how we have the mean, the median, the mode, standard deviation, all these different things to summarize data. Those are all summary statistics trying to summarize data. The test statistic does the same thing, however, it's in reference to our null hypothesis. So it's just going to be one single value. It's going to be one single value that's going to be summarizing the data as well. It's just going to be in the frame of the null hypothesis. Now, this test statistic means nothing to us. We don't really interpret it in any kind of way. But what we can interpret based on that test statistic is what's called a p-value. We kind of do a little bit of conversion, right? And all a p-value tells us, this p here is short for probability. And it tells us how unlikely our test statistic, and we know that the test statistic is the summarized data, right, in reference to the null. That's telling us how unlikely that test statistic would be if the null hypothesis were true. Okay, and this is always right. We try to stand on the null, right? We want to beef up the null hypothesis as much as we can. So any difference that we do find based on newly collected data can be trusted, right? And not just due to chance. Now you can read all of this. You can read all of this on your own. But the big thing that I want to say is this, right? This is a very important little bullet here. Typically, we have a sort of convention, and the convention is we are very cool with there being a 5% chance that our data is just due to chance, due to random chance, okay? And we always use this 0.05 sort of as a comparison, right? As a sort of threshold, right? So the lower our p-value is, the lower is below this alpha level. Okay, no big deal about alpha. As far as what it's called, it is typically 0.05. But the smaller our p-value is away from 0.05, the more evidence we have to suggest that our alternative hypothesis could be the new norm. Okay, so that's a little bit up and out there. And what I'm going to do is I'm going to show you an example here in just a second. But to find p-values, all we're doing is finding the proportion of the area underneath a normal curve, which we've done before with z-scores, right? When we're trying to find that probability or a percentile, right? But what we're going to be doing instead, and I'll draw it just sort of briefly, our normal distribution looks like this, right? And let's say that our alpha, our 5% of the curve, let's say, is right over here. All we're going to do, and that's 0, right? All we're going to do is plot our test statistics somewhere on here, and then whether it falls inside or outside of the shaded area is going to tell us whether or not we can trust our data and trust whether or not that difference is true. Okay, now, blah, 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 right? That's a sort of convoluted, I hope it's not too convoluted. I hope it's not too convoluted, but let me draw you a picture. And let me put it back into the frame of reference of our original example. Okay, so the example was that brown thrashers make up 38%. That's the null hypothesis. And then our alternative hypothesis is that it is not 38. Okay, no big deal. We know that both of those most likely that 38% was also from a sample, right? We could say that it's well trusted, whatever, but that's the status quo. We know that let me do a different color here, that based on the central limit theorem, this proportion, the sample proportion, comes from a distribution that looks like this. All right, so this is the mean. Very cool. All right. We collected data, and it turns out that that sample proportion was 0.34. It's 0.34, and we could say that it's right over here. 0.34. All right. Now, here's what we're doing. We're going to try to figure out if we accidentally sampled something that is still realistic but less likely to happen, where if we were to do it again, so resample, we might get something closer to here. We might, right? Okay. So what we're going to actually be doing, in the whole, right, the kind of big picture here, let's say that our null value is over here, and it's 0.38. And we'll assume that it has a normal distribution, right? This is just for our test. So it looks something like this, right? Okay, very cool, very cool. And then we collected data. And let's assume that it also came from a distribution that looks similar to this, but instead of its center being 0.38, we're going to assume that it is actually our new proportion that we got. So 0.34. 0.34. Like so. And the general idea, and let me actually do it like this. 0.34. And the idea is it's got its own distribution too, and we'll assume that it's also a seemingly normal distribution, but its new mean is this 0.34 rather than the status quo. Based on that, what we're going to do, right, so it looks way like does that, right, that kind of thing. What we're going to do to find the p-value is we're just going to find the area underneath where both curves are, the area shared by both of the curves, right? So it goes way out here, and this is still going to be some area, right? It's going to be some value between 0 and 1, all right? This is going to be, let me be a little bit cleaner here. This, good Lord, this is what I meant to do. Boop. This area, that's going to be our p-value, right? And if the p-value, I'll say the p-value, if it's less than alpha, which in this case, we pretty much always say unless it's specified otherwise, if it's less than 0.05, we're going to go with our new alternative hypothesis. We're going to say that the null hypothesis we're going to say is bunk, right? And then this 0.34 is maybe the new status quo. We'll suggest that we have enough evidence to say that it's the new status quo. Okay. And that's really what's going on under the hood. Actually, I'll keep that there. Boop, boop, boop. Say it like this so you have it. Okay. So essentially this is what's going on under the hood. This whole process, though, of actually finding areas underneath curves is a pain in the ass. And I'm not going to have you do it, right? It's calculus and blah, blah, blah. However, we do have some easier tools to use, especially online. If in fact, we'll be using the same tool that we used for the z-scores. We're just going to be using a slightly different sort of context, we'll say. Okay, so if you didn't write this down, don't worry about it, because we got it on the next step, step 5. And in fact, I'll just leave it at this. So kind of take this in. Let me actually draw this too. Like that. Very cool. Okay. All right. I'll leave it at that. So I will see you here in just a little bit.